Hi, I'm Bianca Coker, and today I'm going to share a few insights into one of the new math standards, specifically 7.6H. This standard states that students apply mathematical process standards to use probability and statistics to describe or solve problems involving proportional relationships. The student is expected to solve problems using qualitative and quantitative predictions and comparisons from simple experiments. If we conduct an experiment like flip a coin and record that data, that's the information we actually use for experimental probability. Unlike theoretical probability, when we know that we flip a coin, we have one of two possibilities, and so our probabilities are very simple, 1 out of 2 or 50% for each of those. In experimental probability, we ignore that fact that we know, or sometimes we don't know that, and that's why we conduct an experiment, and we look at the data we get from all of these trials that we've conducted. In this table, you see that we've conducted 7 trials. We flipped a coin 7 times, and the outcome for each trial is recorded in the table, where H represents the heads part of the coin lands up, and T, the tails part of the coin lands up. So with this the experiment we've done, we can calculate the experimental probability. So let's look at that. If we look at the number of times or the number of outcomes in the trials that resulted in heads up, we see that that happened 4 out of 7 times. So then the probability of heads is 4 out of 7, which is not 1/2. But that's what experimental probability is all about, looking at the data and calculating the probability. So if we calculate the probability of tails, we'll see that that happened 3 trials out of 7 total. So the probability of tails in this situation, the experimental probability, is 3 out of 7. So based on this historical data, we have our probabilities. And from this data, we can make predictions. Now the standard said we want students to make qualitative and quantitative predictions. The qualitative is a little different for most math people. So we're going to start with quantitative first because we're a little more comfortable with that. Quantitative means numbers. So what we're looking at are the actual values in the probability. So when I say the probability of heads landing up based on our experiment is 4 out of 7, that's a quantitative statement. If I want to make a qualitative statement, this is a little different. If at the end of this video you're still confused about qualitative versus quantitative, I can assure you your science teachers know all about it. So in qualitative, we're making a statement that isn't really numerical. In the current math standards, the 2006 standards, students as young as in kindergarten work probability problems, but their answers are very qualitative. They use things like likely, not that likely, more likely than. And they have been using those since kindergarten, 1st and 2nd grade. So what we've done with the adopted 2012 standards, and we move probability out of elementary and into the middle school, is the students no longer, after a few years, will be exposed to those kinds of qualitative statements. So that's what we're going to be doing now in middle school. So in this experiment, for example, we might say the probability of flipping a coin and it landing heads up is more likely than it landing tails up. And that's an example of a qualitative statement. Let's look at one more example. Perhaps. There it is. So if we were to roll a number cube, a fair number cube, and you know the outcomes can be 1, 2, 3, 4, 5, or 6 dots, and we record for each trial the number of dots that landed up on the cube, we might have gotten these kinds of outcomes. So if we look at this, we have 7 trials total. So if we were to calculate our experimental probability based on this experiment, then our denominator is always going to be 7 because we did 7 trials. So if we find the probability of rolling the fair number cube and 1 appearing heads up, that didn't happen at all. So there's 0 times that we rolled in the fair number cube and 1 appeared. So that probability, technically, that quantitative prediction is 0 out of 7 or 0. The probability of 2 being showing on our fair number cube happened 3 out of 7 trials, so that probability is 3/7. And for the rest of the numbers, 3, 4, 5, and 6, those occurred 1 trial out of 7, so the probability of that occurring, that experimental probability, is 1/7. So based on the experiment, we can make these quantitative statements. Looking at the data, we can make some qualitative statements. Think for a minute about the kind of qualitative statements you might make looking at this data. You probably said, it's not likely that we will roll a fair number cube and get a 1 based on this data. And you might have said, I would really like to put money down on getting a 2 rolling this fair number cube because that has the highest probability. Of course, we wouldn't do that, and we certainly wouldn't say that to our students. But this gives you an idea of what you think most likely might happen in the future. And so we would say that the probability of rolling 2 is the most likely thing to happen, or more likely than those others. So that's all we're talking about, really, when we're talking about qualitative and quantitative kinds of statements from experimental probability. So with this standard, what we really want students to start understanding is why we're doing probability to begin with. It's not just because we want them to learn fractions. It's because we want them to look at either the theoretical or experimental data in the world and make predictions about the future. Make predictions about what might happen next. Make predictions about what might not happen next. And so we can all make better decisions. Thank you and have a great day.